So how's it going? Today we're looking at this DIY LED grow light that I just finished. So a little background, so I was into hydroponics for peppers and lettuce a few years back. I used the Cree method and that was kind of fun. So I had designed this thing a few years ago for that purpose, and so I kind of got out of the hydroponics and I had this stuff laying around, and rather than part the parts out, I went ahead and finished the build, and I'm going to let a friend borrow it, and so he can use it. So what we have is 11 Cree CXB 2540 LED chips. It's kind of a mid-range, you know, you can definitely get bigger chips, so it's kind of a mid-level, mid-size chip. And so they are all in series, so they're a 36 volt nominal. And then I'm going to run them at half an amp. They're good for like 2.1 amps or 2100 milliamps. So kind of running them very softly, but that's okay. So at that, they should be about 33 and a quarter, thereabouts, volts. So the whole thing will be about 365 volts there. And so you can see the driver in the upper right-hand corner there. It is an Meanwell HLG 185H-C500A driver, so good for, you know, a couple hundred watts. So this whole thing should be about a couple hundred watts. I have 2 fans on each heat sink, and how it works is so that's aluminum angle there on the so that's aluminum angle here, so that's 30 inch or 2.5 feet. And then our horizontals those are heat sinks. I will show you the other side where the fans are when we get to that construction kind of section and kind of how I built it. I do have, you know, I kind of did this over the course of weeks, a long time, 10 minutes here, 10 minutes there. I didn't have like a hard deadline. And so I did kind of film as I went, but I think maybe just this will be a little better just going over it. It's not that complex. So the build stuff, I don't think we'll need, if we want to see it, maybe we could do it, but I'm going to go that route for this video. So the heat sink they're 3 feet long, 36 inch long, 3 heat sinks. It's from heatsinkusa.com. It's their 2.079 profile, I think, going from memory. So there's 4 LEDs on the outskirts, on the outside heat sinks, and then 3 in the middle, so that kind of avoids a hot spot in the middle. So alright, I thought about maybe going through the data sheet on the video, but I think we'll skip it. I'll just kind of give you the highlights. So at half an amp, these chips should spit out just under 3,500 lumens a piece. About 3,470 lumens times 11, that's about 38,000 lumens, or equivalent to 42 60 watt incandescent light bulbs at 900 lumens per. So just if you get a feel for size, 42 60 watt bulbs, so that's kind of a chunk. The color is, so LEDs have different color ranges, and it's 4,000 Kelvin, I think, is the color range. You know, it's kind of mid-range color, so the lower you go is warmer color, and then the higher you go, there's more blue. So more red on the low end, more blue on the high end. So this is kind of in the middle. So I did use that color, that 4000K color, in a smaller form factor for the peppers and lettuce that I was doing. It seemed to work okay, but I don't know if that's just what I have on hand, so I don't know if that's like an optimal color. So we're kind of, I'm gonna let my friend use it and see what happens. Pretty much that's what's going on. So next up, let's just quickly go over the construction. It's not too complicated, so let's get into that. Alright, so I've got you off tripod. Here's a look at just kind of the construction. So I drilled and tapped the angle onto the heat sinks with 4 screws. They're M3s, kind of short stubby ones. I think maybe 6 millimeter. So I used to tap, I used this little Ryobi 8 volt, And then so you just go back and forth with it, and it doesn't have too much torque where it blows through the threads. And I use double WD-40 for the cutting fluid. If I had proper cutting fluid, I'd use that, but that seemed to go fine. And then onto the chips here. So here they are. I've run 20 gauge wire, so they're all in series. So they just a big loop in series, and so what's taping them, so I've got capped on tape, so it's like high temperature tape, just taping down the 20 gauge wire. So it's a 1/2 amp going through the 20 gauge wire. Same kind of thing here with the chips. So so it's drilled and tapped here. This is the chip holder, and then below the chip I have double stick heat sink. So it's double stick heatsink tape. There's a few options. I like the tape, and so I wouldn't even need this holder because it's so strong, but I put the holder on anyway. On here is, if I can get it, that is liquid electrical tape, that white stuff on the connections, just to keep it insulated. So it's kind of like rubber cement or whiteout, really. So it's kind of a little rubbery business that you just kind of put on the terminals. All right, so there's the JST out or in from the driver. So just a quick JST connector. Try to get a focus here. So that goes out to the driver. So here's a look at the driver. Meanwhile, HLG 185H C500A. That little guy at the top here, the little plug, you can adjust, the current on it if you want. They make other ones where you can do PWM current adjusting. They're a little more money, a little more complex, but I haven't. I just use these ones. So that's the 2-wire DC out. This thing's good for 400 volts. Give or take, and then 1/2 amp. So that's the driver. Here's the driver. So when you get the driver, it's just the 3-wire out. So it's AC and 3-wire. The orange plug there is from Home Depot, and then I looked on the internet for the pinout for live earth and ground, or live neutral and ground. So this just splits apart with screws. And you jam the wires in and screw them down, and then screw the plug in. It's pretty straightforward. Just double check and be careful with AC. I'm a low power DC guy, but that's pretty straightforward. Alright, here's the other plug-in component. So it's 2 plug-ins for this light fixture. This is to run the fans. So that is a little, you plug that in, it's 12 volt DC out, I think for a couple amps, good for a couple amps. And then I have 6 fans on this unit, and then I have a different style connector, so you don't mix up the driver and the fan connector. This is a buck converter with a voltage meter on it, so you can adjust the buck converter down and reduce the voltage and drop the fan speed, maybe save a couple watts, but I have it just running full on. Yeah, I just have the voltage on the fans running full on at the moment, so they won't draw too much, but I haven't yet tested to see if you could drop the fan voltage and still get good cooling and save a few watts. So I haven't done that yet, but it's doable if you wanted to. So next I'll just flip it over, we'll look at the fan situation, and then we'll test it. We'll run it. Alright, so here's a look at the fan, and then what I did was I just put holes at each corner, and then you can hang it with these little carabiner guys. So pretty straightforward. Also the driver is separate, so to wall mount that and kind of mount it separate from the I gave it some like 2.5 feet of, so I gave it 2.5 feet of wire so you could wall mount the driver so it's away from the fixture, and a little better cooling, that way, heat action. So here's a look at the fan. It's a 2-inch fan. It's a sun on, maglev bearing, so better than like a sleeve bearing. I've got lots of hours on this kind of fan, and I like them. They're pretty good. 12 volt. Model number is KDE 1205 PF V3. So two fans on each heatsink, 1 foot in, so we got equal distance, and they're all in parallel. And then it's not a lot of real estate, so I do have zip ties in the middle there. It's kind of less than ideal, but there's not a lot of real estate to work with. If I had a bigger heatsink, you could, tape the wires on the side, that kind of thing. But I think it'll work. It's not supposed to play football. It's just supposed to hang around and spit out light. The fans are just stuck on with double stick tape, so I used some 3M stuff, so it's pretty strong. You might be able to find a clip or something like that. I didn't want to drill holes in the heatsink or anything like that. So, all right, so I got it plugged in. Hopefully it's coming through okay. The bright light tends to wash out the camera a bit. So I've got it plugged into solar, so I can tell what it's drawing. So through an inverter, we're just under 250 watts. So with my testing, I wasn't sure if 2 fans were going to do it, but it turns out it's good. I tested it for a couple of hours, and my goal was to make sure that I like to run my LEDs cool, so pretty much room temperature, so you just get more light for less juice when you do that. And my goal was just to be less than 10 degrees Fahrenheit over ambient, and that's what we got. So I was getting 63 or 64 degree Fahrenheit ambient temps here in the basement, so kind of cool, but I was getting about 68 to 70 degree Fahrenheit, temps on the heat sink, so not too much, nice and cool there. And as far as the driver, it was on the cement floor, and it was at about 93 degrees Fahrenheit. So that was with about 2 hours of testing. So this hopefully this works. I don't know if I'm kind of been out of the game on grow lights and how things work. So maybe 6 months down the road I'll know more and I can add something in the comments. Kind of another idea before I kind of went off on other interests is to kind of use a light as kind of your main light, and then you can add blue for vegetative growth, for just growing the plant, and then skew the light more towards red for the harvest time, to get it to flower and produce whatever fruit you're growing. And what I was thinking, you could do that with a smaller heat sink and a string of 3 watt bead LEDs. You got blue ones for veg, and then you could switch off the blue and switch on the red for flowering. So that way you'd have kind of an all-around light. But that's kind of, I haven't tested that. That was just an idea. And then how many LEDs, like how much red do you need and how much blue do you need, that kind of thing. So, but that was an idea down the road that I was thinking about. So anyway, that's it. I'm going to go over my notes and see if I missed anything. So that's it for this project, guys. Have a good day.